So hello everyone, welcome back to another new video. In this video we are going to solve one important numerical, and this question is asked in 2019 spring. Okay, so this will be very important for our final examination. Okay, so let's solve the numerical. So if you are new to the channel, please do like, share and subscribe. So first read the question. In the given question we have a given frame. Okay, we can see this is given frame. Okay, in this given frame the question is given, and in the question you can see here, use moment distribution method to analyze the frame in the given below. We have to analyze the given frame by the moment distribution method. Okay, and we have to draw the BMD, and we have to draw bending moment diagram as well. Okay, so if you look towards our question, you can see here we have a four different joints. First hinge at A, okay, and B and C as intermediate joint, D, E and F, these three are the fixed support. Okay, and the total height of this is 6 meter. Okay, and one more thing, in very first we need to understand either our given frame is sway or non-sway. In very first we need to determine. Okay, so as we know, in this given frame you can see here, this frame is fixed. Okay, laterally. If the load is applied over here, and if this frame starts to sway like this, then you can see here, this is, here is a fixed support is provided which resists the this lateral movement. Okay, whenever the lateral load is applied over here, it will start to sway like this, but here is a fixed support. Okay, this fixed support resists this frame to sway. Okay, so it means whenever the fixed support is given, okay, so it means this free support helps to this frame not to sway. Okay, this will help in um, sway mechanism. Okay, whenever this frame try to sway, this uh, fixed support resist this. Okay, and then finally this will be non-sway. Okay, so from here we can conclude that this question is for the non-sway analysis. Okay, in which first we need to understand either it is sway or non-sway. So we will solve any moment distribution problem in three steps. Okay, first step is fixing moment calculation, second step distribution factor table, and third step moment distribution table. Okay, so in very first we need to calculate the fixing moment. So from here to here you can see this is a point load. So we can apply the point load formula. In previous video and slope deflection we have seen different formula for the point load. We have formula. Okay, and for B to C this is the UDL, so we have UDL different formula, and this is C to D, this is also point load, so we have to apply the point load formula. Okay, so now apply the formula and calculate the all fixing unit. Okay, so here I think now I don't need to understand the fixing moment calculation because we have already done more than 20 numericals of slope deflection and moment distribution. Okay, on all that videos we have calculated fixing moment, so I don't need to show more until in detail. Okay, so first let's directly apply the formula and calculate the fixing moment for the MA. You can see here the formula is minus W L by 8. Our formula is minus W L by 8 because this, whenever the point load is acting in the middle span, okay, then this formula will be applied. And you can also apply PAB square by L square as well. Both are the same formula, you don't need to confuse. Okay, so this value will be minus 22.5. Okay, and for UDL this is for point load, and for BC, okay, so for BC our formula is for the UDL. Okay, we know the formula is minus WL square by 12 for the left side. So this will be minus WL square by 12 and our value will be minus 31.25. So for the right side this will be just plus. So this will be 31.25. This is for the BC and this is for the CB, just opposite letter. This is for the AB and this is for the BA, just opposite letter. This will be minus, this will be plus. That this much. Now again for the CD, okay, you can see here in both case we have, okay, for the AB section and for the CD section. Both case we have a 60 kilonewton load over here, 30 kilonewton load for the AB. But you can see this is 3 means this load is acting at the center. But in this CD span, this is 2 meter and 3 meter. So these two are the not equal distance. So we need to apply this formula PAB square by L square. Okay, and in this case we can also use this formula. Okay, don't not to worry, and you can also use that formula WL by WL square by 8. Both are the same formula because when you take the value A and B equal, then we get this value WL square by 8. Okay, so whenever this um, point load is different distance, so we have to use this formula. So for this CD section, you can see the fixed load is calculated by the formula P means minus 60, A means 2, B means 3, L square. 2 plus 3 means 5 square is this much. Okay, for opposite C to 2 and D to C, just we have to change the formula. For left side PAB square by L square, and for right side PA square B by L square and plus only this much. So this will be 28. And for EB and BE, there will be no load applied over here. You can see for these two sections there will be no load, so the fixed moment will be 0 for the BC and for the EB, also for the CF and for the FC both. So we get the value 0 0 and 0 0. So we have completed the first step. Now let's go in the second step. Okay, so second step is moment distribution factor table. Okay, so in distribution factor table we have to first write the joint. So in the given frame we can see we have B and C joint. Okay, so first C in the figure you can see first we have to write the joints. So intermediate joint is B and C. So at B we have two member connected, BA and BE and BC, three member. And for joint C we have also three member, CD, CF and CB. So first write the joint and their member connection, connected member. So as I said, we have three. For the B, we have three different member joint. For the C, we have three different member joint. Okay, now we need to calculate the value of K. That is the uh, distribution factor. Okay, first we need to calculate the value of K, then sum K, and then we can calculate distribution factor. So for the value of K, you just need to two things. Okay, we have the two formula only. First one is 4EI by L and another one is 3EI by L. Okay, so in these two formula, when we apply this formula and when we have to apply this. So for this, you always remember, we have to always apply this formula 4EI by L. Okay, always, never get confused. Okay, but in only one case, whenever our in support is hinge, then we have to apply 3EI by L. Only this much, nothing else. Okay, so you can see here in this uh, frame you can see, as I said, we have to apply always 40 by L. It means and except hinge support, so it means this is the hinge. So from B to A to B, if the hinge, then distribution factor will be 0. Okay, but now we are going to determine for the intermediate, means B to A. It means this hinge support is at the end point. Okay, so at the end point, whenever the support is hinge, then we have to use the formula 3 EI by L. and remaining in all we have to apply 4 EIBL. Only this much change. We have to use this 4 EIBL always for the all time from here to here, from here to here, because this is fixed, this is intermediate. So whenever there is a fix, whenever there is an intermediate, we have to apply always apply 4 EIBL for the value of k. Okay, and in only one case, that is the hinge support, we have to apply 3 EIBL. Only this thing will change. Okay, so let's calculate. So as I said, for the hinge support, that is BA, we have to apply 3 EI by L. So 3 EI, L is the 6, so this was 0.5. So for the BE is the, as I said, this is the hinge support, this is the fixed support. Okay, this one is only a hinge. You can see here. So for this value only we have to apply 3 EI by L, and all the remaining value we can see. This all the remaining we have used 4 EI by L. Okay, nothing will change. So only this much. And L means we have to apply the respective value. This is 4, this is 5, this is 5. So finally you get this all the value. Okay, never confuse. Now you can see we have to add this all the value. We have to add this all the value, that is 1.8, and we have to add this all the value. We get 2.1 a. Okay, only this much. Now we have to calculate distribution factor. So distribution factor can be calculated. We have to divide this individual value, okay, this individual value by this, means 0.5 by 1.8, we get this one. 0.5 upon 1.8, this 0.8 divided by this, we get this value. Now for joint C, you can see we have to just divide this by this, we get this by this, we get this by this, we get this. Okay, so from here we got the distribution factor. Okay, you can see here this for this joint B. Okay, you can see it for this joint, and if you add this all the value, you get this all value 1. It means the sum of all distribution factor at a point will be, at a joint will be 1. Never forget this thing. Okay, and for the here also you can see our joint is C. If you talk about a joint C, the sum of this all the distribution factor will be 1, should be 1. Sum of the distribution factor at any joint. How? Don't, it does not matter how many members are connected at that joint. At any joint, some of the all members should be, and their distribution factor should be equals to 1. So if you sum this all the value, you get the value of 1. And if you sum this also, you get 1. Okay. So from here you can also check whether your distribution factor is right or wrong. Now we need to make moment distribution table in third step. Okay, this will be our final step. So in moment distribution table, you have to always remember, in very first we need to write joint. So always keep in mind we have to write the joint sequence wise. It means first A, B, C, D, E and F. We have total 8 joints, so we have written over here. And if you look in the frame, then you can see we have to write the respective member of a joint. So at joint A, we have member AB. For joint B, BA, BC and B. For joint C, CB, CD and C. For joint D, DC. Okay, we have to write the respective member. So this is very easy, not to worry. So for joint A, we have write member A. For joint B, we have 3 different members, so we have written here. For joint C, we have also 3 members, so we have written here. For D, only 1 member. C, only 1 member. For F, only 1 member. Okay. Now, in very first, after joint member, first we have written member, then distribution factor we have to write. So as I said, whenever the end support is hinge, okay, and from any point to that hinge support and hinge support at a end point, okay, so their distribution factor always 0. Remember this thing. So it means this value will be sorry, always 1. Okay, okay, so we have to take this value 1, and whenever the in support is fixed, then we have to take always distribution factor 0. Okay, so for the distribution factor, for as you know, we have three different support, that is DE, D, uh, EB and FC, and the fixed end are fixed, so their distribution factor should be 0. So these three value will be 0. Okay, and for the hinge support we have to take distribution factor 1. So this will be 1, and these all will be 0, 0 and 0. Okay, and we have calculated already in the second step distribution factor of BA, this one BE, this one BC, for CB, for CF, for CD distribution factor this one. So this is we have already calculated in the above table, and we have just put the value in this here. Now we have to write the fixing moment. So in from first step we have to write all the fixing moment and keep in this. Okay, so we have done this all the things. Now look here. Okay, so I just want to clean this all the value, then you can easily understand. We have to measure two major steps. Okay, so you can see here we have two major steps. So first one is balance. Okay, so in the balance, in very first we have to balance the hinge support. Okay, whenever we have the hinge support we have to balance it. So we have a minus 22.5. So we have to, for the balance we have to do nothing, we have to just change the sign. Okay, so we have fixing moment minus 22.5. So for the balance we have to just, okay, so you need to understand, listen carefully. For the balance we have to always, in very first step we have to always balance the hinge support. Okay, so this AB is our hinge support, so we need to balance. So for the balance we have to just change the sign. Okay, minus 22.5, it means change the sign, that is 22.5, and we have to multiply with the distribution factor, that is 1. So we got 22.5, and these all the value we don't need to do anything because these all are the except hinge. We have to only balance the hinge support. So this value we got. Okay, and in second step we have to do carry over moment. Carry over moment means we have to just transfer half moment of this to their respective neighbor. It means the neighbor of this AB is BA, so we have to transfer half. Half of 22.5 means 11.25, so we have to transfer to the respective neighbor only this much. So now let's add this all the value. So finally total we get this value. Okay, this all the value we have to add this all the value. So in this step we uh, get first step, and similarly we have to follow the further one. So if you understand this thing you can easily do next step. So let's see, this is also very important. Now we have to, as I said, we have, this is the hinge support. So as we know hinge support never carry moments, so this will be 0. So now we don't need to do anything. Now look here, for the B joint you can see here, for the B joint we have three different members. Okay, so for the balance we need to add these three value in very first, add all the value. Okay, add all the value. After adding this all the value we get some value. Okay, and in this case we get this all the value. This is 33.75 and minus 31. So after adding we get 2 point something, positive 2 point something. Okay, so we need to change the sign. So we get 2 point something, so we have to change plus, so we have to change the sign minus. We change the sign and we have to multiply with the distribution factor, this for the BA, and multiply with the distribution factor. So it means this we get this value. Again sum this all the joints, all the members at a joint B, and change the sign and multiply with the distribution factor. So 0, our distribution factor is, sorry, 0.25, so we get minus 0.7. Again for this one we have to add all these uh, total value at member B, okay, and we have to change the sign and multiply with the respective distribution factor, and we get this value. I repeat, similarly for the point joint C we have three different member, so we have to add these three value. I repeat, we have to add these three member value and we have to change the sign, okay. Whenever if minus, then we have to change the positive plus, and if plus, then we have to change the minus, and then the result value should be multiplied by their respective distribution factor. So 0.3 if we multiply, we get this value, okay. And again for this CF, add these all three value, multiply with their distribution factor and change the sign. Again for this 3, add this 3 and change the sign, multiply the distribution factor and keep here only, okay. And for this joint D, you can also see here, this is our distribution factor is 0 0, so if we multiply by the distribution factor, then this all value will become 0, so we don't need to write, okay, because if we multiply the this value and with the distribution factor, this all value becomes 0, so we don't need to. Now in second step we have to again do carryover moment. So as I said, in carryover moment the moment will always go half to the neighbor, okay, neighbor member. So you can see for the carryover moment this will be BA, so it means the neighbor of BA is AB, so half of this will go in AB. But in previously as we seen, this AB member is a support say, so this AB will be not participate in the sharing, okay, so there will be no transfer because we have already closed this portion. So it means now we have to change for the B. So the half of B will transfer in the EB. So where is EB? You can see here this will be. So half of EB will be transferred over here. So it means in carryover moment you can see here this 0.7, half of this value will be transferred over here in neighbor value, in neighbor member. So the half of BC, so the half of neighbor is just you have to change the letters. BC means we have to change CB. So half of this will be goes in CB. So half of minus 1.1 will be here, and half of CB this goes here. Okay, and for CF, half of CF goes to FC. So half of CF goes to FC over here, and half of nothing here. So this value will be nothing. Okay, for the CD, half of this value goes to the DC. CD, their neighbor will be DC. So half of this over here. And here 0, so here will be nothing. And for DC, similarly, okay, in this way we have to just carry on. So in this way we get completed these steps from here. Now again we have to again balance and again carry over moment. So similarly we add these three value and multiply, change the sign and multiply with distribution factor and we get these three value. Similarly for this joint we have this joint, okay, so we add this value, multiply with the distribution factor and change the symbol we have written here, and similarly this value, okay. And for the carryover moment we have to just transfer half to the respective neighbor. If the member is BA, then in uh, balance, sorry, in carryover moment we have to just transfer half of this to the BA portion, AB to BA and BA to AB, only this much. And finally we balance, okay, and after balancing we add all these value and we get this much value, okay. This will be our final moment. Now we got all the values, okay. Now we just need to plot bending moment diagram. So in bending moment diagram it is very important. So first we have to plot all these given value, okay. So just put this all the value, and during the putting value this, you have to remember and you have to follow this sign convention always: minus, plus, plus and minus. Okay, so when you move from left to right, we have to take minus sign as a upper part from the beam, and from right to left we have to take positive value as upper of the beam. Okay, and from left to right, positive value is in up below the beam, and from right to left, the negative value will be below the beam. So from A to B, this is nothing, so we have 0. From B support, we have the moment is 32.4. So this is from B to A, we are going to from right to left side, so this is positive value, so we have to go up, so this will be up. Okay, similarly for the C, we got 35.3. Okay, so from B to C, and this value is C to B. Okay, so C to B, this is positive value, so this is written over here. Okay, and similarly we have 31.17 from D to C, this is also positive, so we have written over, and we have to just add, we have to just join these all the points. Okay, similarly for this portion also we have to just join. And now we have the point load. Whenever we have point load, we have to apply the formula, this one, PAB by L. Okay, or we can also apply W, this formula also, but I suggest you have to always apply this formula, PAB by L. It means the PB is point load and AB distance, you get 25. So we have to put like this. And for the UDL, okay, we have to apply this formula, WL squared by 8 for the maximum moment, WL squared by 8. So you get 46.8. So you have to make a curve and do. Now you need to understand when is plus and minus. So in previously we have made this curve. So above than this moment curve will be plus. Okay, plus, plus, and the below than this portion will be minus, minus. This will be minus. So this was it. Okay, hope you guys understand very well. Thanks for watching. See you in next video. Thank you very much.